Right, so let's do some more writing formulas practice. This is page number 100 in your notes book. And just make sure that we need to, when writing our formulas, the positive ion goes first and then the negative ion. And then we're going to crisscross so that balances out the charge because the sum of the oxidation numbers is going to be equal to 0. So I'm going to work across the row. So I'm going to start off and we're going to do our symbols. So Na and Cl. Since we have a positive 1 and a negative 1, those cancel each other out. So that stands the way it is, sodium chloride. So now I have an Na symbol and I have an O. And I have a positive 1 and a negative 2. So positive 1 and a negative 2. So then when I crisscross, I'm going to bring the 2 of the oxygen across, right? So then I'll just write that over here. So it's a positive 1 and a minus 2. So then when I write it and I crisscross, I'm just going to erase that so we can keep it as it is. Okay, so now I have my sodium, which is a positive 1, and my phosphorus, which was a negative 3. So now I crisscross and I bring the numerical charge, the number is going to form that subscript. So then the phosphorus has a negative 3, so I'm going to bring the 3 next to the sodium. It's going to go onto the opposite element, and then the 1 for the phosphorus. And so we don't write the number 1. So then now this formula is balanced with a negative 3 and 3 positive 1s. So now I have my positive 1 sodium, and I have now this is a polyatomic from table E. This is the hydroxide ion. And so that's going to go in parentheses. And I have a positive 1 and a negative 1. So then that's all set. You can also, since you only have 1, you can eliminate the parentheses if you would like. But you're not necessarily wrong to have the parenthesis there. So now I have my positive 1 sodium. And now I have the sulfate, so which is our SO4. I'm going to put that in parentheses. That's a negative 2. That whole thing, well, that looks like a 9. I'm just going to erase that just so it looks a little bit better here. Oh, sorry, not highlight. I wanted to erase. Here we go. All right, so SO4. So now I have a positive 1 and a negative 2, right? This is a negative 2. So I'm going to bring the 2 down to the sodium. And since sodium is a plus 1, the sulfate is just going to stay as a 1. And so I can just, so my erase function doesn't work so great today. There we go. All right. So now I have my sodium, which is a plus 1. And now I have a phosphate, which is a minus 3. I'm going to put my polyatomic in parentheses. And so now I have a 1, a plus 1, and a minus 3. So I'm going to take, I need 1 of the phosphates, and I'm going to need 3 of the sodiums. All right, so as we go on, I'm going to not erase. Oops, sorry, let me put my parentheses back on there. All right, so now I have calcium, and I have chlorine, and I have a positive 2 and a minus 1. So I'm going to take the 2 becomes the subscript of the chlorine, and then the 1 is the subscript for the calcium. So now I have a negative 2 and a positive 2, and my formula is balanced. The sum of the charges is equal to 0. So now I have a calcium, which is a positive 2. And my handwriting is atrocious today. I have a calcium, which is a positive 2, and I have an oxygen, which is a negative 2. So then since the charges are the same, they cancel each other out. No need to crisscross. Now this one I have a calcium, which is a positive 2. And now I have this phosphorus, which is a negative 3. So when I crisscross, I'm going to make 2 my subscript on the phosphorus. I'm going to make the 3 the subscript on the calcium. So now my charges are balanced with a positive 6 total and a negative 6, which sums up to 0. And again, when you write the formulas, you would just then, where you write the formula, you have better space as with that. All right, so now I have a calcium, which is a positive 2. And remember this, the charges are on the periodic table. And now I have the hydroxide as a negative 1. So when I crisscross, I'm going to bring the subscript to the outside of the parenthesis because I'm not just having 2 hydrogens, I have 2 hydroxides. It functions as a group. And then just 1 calcium. In my next one, I have calcium, which is a +2. And then I have my sulfate, which is a -2. And since the charges are equal, no need to crisscross because it's already balanced. I have my calcium, which is again a +2. And now in this case, I've got the phosphate, which is a -3. The whole thing is a -3. So now I need to crisscross. I'm going to take the 2 and I need 2 of the phosphate groups. Remember, the polyatomic ion functions as 1 unit. And then the 3 comes down here. And so now there's my formula. And so now in my next one, I have aluminum, +3, and a chlorine, which is a -1. So now I'm going to crisscross. That means I need 3 chlorines and 1 aluminum. Now I have aluminum, which is a +3, and I have an oxygen as a -2. So when I crisscross, that's going to be a 3 and a 2. Now I have aluminum, which is a +3, and a phosphorus, which is a -3. The balance, their charges are the same, so it's just ALP. So now I have aluminum with a +3, and I have this hydroxide. This whole thing is a group, it's a -1. The whole group is -1. So when I crisscross, I'm going to bring my 3 down here, and then I need only 1 aluminum. And so now my formula is balanced with -3 from the hydroxides, +3 from the aluminum. So now I have aluminum, which is a +3, and then I have my sulfate, which is a -2. And so when I crisscross, I'm going to need 3 of the sulfates and then 2 of the oxygens. And again, my 4 looks like a 9, sorry. And here I have my aluminum, which is a +3, and I have my phosphate over here, which is a -3. So then I don't need to crisscross because the charges are equal. So now I have iron. Iron is a +2, and I have my chlorine, which is a -1. So when I crisscross, I need 2 chlorines and 1 iron. And I have iron, and I have oxygen, the +2, -2. The charges are the same, so I don't need to do any crisscross. Iron, +2, and I have a phosphorus is a -3. So now I'm going to bring the 2 down to the phosphorus, and I'm going to bring the 3 down across to the iron, right? We're crisscrossing, which balances the charge. I have a +6 and a -6. So now I have my iron, +2, and I have my hydroxide. This whole thing is a -1. So then I need to crisscross. I need to bring the 2. I need 2 hydroxides and 1 iron. I have my iron being a +2, and now I have my sulfate, which is a -2. And so since the charges are equal, I'm all set. The formula is good the way it is. Iron being a +2, you see the pattern by now, I'm assuming, and phosphate is the PO4. This whole thing is a -3. So when I crisscross, I need 3 of the +2 irons, and I need 2 of the -3 phosphates. And because now I have a neutral formula, the sum of the charges is +6 and -6. So now I have iron, which is a +3. And I have the chlorine, which is a -1. So when I crisscross, I need 3 of the -1 chlorines and 1 of the irons. Iron as a +3 charge, and oxygen as a -2 charge. So then I'm going to bring the 3 down over here, and I'm going to bring the 2 over here. So now that's Fe2O3. Notice these are 2 different iron oxides. They're different formulas because they have combined in different whole number ratios. So here I have the iron being +3, and I have a phosphorus being -3. And so since the charges are equal, I don't need to crisscross because it's already canceled out to 0. The sum of the charges is 0. So now here I have an iron, which is a +3, and now I have my hydroxide, which is a -1. Notice the polyatomics in parentheses, because when I crisscross, I need to bring the 3 to the outside of the parentheses, because I need 3 of the whole group, the hydroxides, and then just 1 of the iron. And so now in the next one, I've got Fe, I've got my +3, and I have my sulfate, which is a -2. And so this whole thing is a -2. So when I crisscross and I take the 3 across to the other side, I need 3 of the sulfates, and I bring the 2 across to the iron, and now I have my iron sulfate. And now here I have my iron, which is a positive 3, and I have the phosphate, which is a negative 3. And so then, since those are equal charges, it's good the way it is because the sum of the charges is 0. And so now I'm going to start with my positive ion being a polyatomic. So then, yeah, my 4s are just terrible today. Maybe if I just make the screen a little bit bigger. Whoa, too big. Crazy zooming. Crazy zoom. All right, let's just see here. There we go. That's much better. Okay. All right. So I have, let me get back to my draw function here. So I have NH4. Okay, much better. And now I have a Cl. So then this is a +1 and this is a -1. So it's already good the way it is. It's already balanced. So now again, I have NH4. And now I have my oxygen, which is a -2. So I have a -2. I wonder what happened to my oxygens over here when I zoomed. I don't know. So then this is a +1 and a -2. So I need to crisscross that 2. But I need to crisscross, I need to put the whole polyatomic ion in parentheses because I need 2 of those ammonium ions. So I have a +2 cancels out the -2. So now let's do the next one. Again, I have my NH4. And again, with my terrible handwriting on my tablet. Okay. So this is NH4. Okay, much better. I just have to take my time and be more patient. All right, so +1. And now I have a phosphorus being a -3. So when I do symbols, charges, crisscross, I need 1 phosphorus and I need 3 of those ammoniums. So NH4, which is my ammonium, and this whole thing is a +1. And now I have the hydroxide, and this whole thing is -1. So now that's +1 and -1 are the same charge, so I don't need to do anything. And I can rewrite that without the parentheses if I would like to. Because you only need the parentheses if you have more than one of the polyatomic. You need to add a subscript. So now I have my NH4, which is my +1. And I have a sulfate, which is a -2. So then when I crisscross, I need 2 of the ammoniums, and I need 1, right? Because I bring it crossed and crossed. So NH4, my ammonium, and it's a +1. And then my phosphate, oops, again, where my 4s are looking like 9s, in kindergarten handwriting. And there we go. And a -3. So then when I crisscross, I need 3 of the ammoniums to 1 of the phosphates. So I hope that you did a good job on this practice. Please ask questions. If you need help, we're here to help you. All right, until our next video, I'll see you later.